Hi there, everyone. I'm here today to tell you a little bit more about the highlights of this Sprocket build project that was developed through the Future Forward program in partnership with OCTI and Open. This is a project that's based on a grade 10 manufacturing student or class, and so this is hopefully catering to their skills at that point. It can be modified, changed, used in other classes as well. It may fit a design class, it may fit a transportation class. Really depends on what projects you're using and building in those areas. So it's free to take and use and modify and change and make work with what you've got as far as equipment and resources and classes available. That's what's kind of great about all of these different pieces, is that they're yours to have and do with what you will. There's some extensions here as well. You can also tie this into an electric vehicle build. So there are a few schools in the province right now building single-seater student-driven race cars for the University of Waterloo Electric Vehicle Challenge. OCTI is actually doing a little bit of work to try to expand some of that with some resources here. So look forward to that in the future as one possible extension to this, sort of simple Sprocket build. It could blossom into something else. Related sectors that this ties to from the open content are auto and parts manufacturing and tool, die, and mold. So those two sectors are the primary areas of focus here. So some things we need to do to actually, or know to actually be involved in this project. Not necessary, but suggested different items. So general shop safety, hand tool techniques, layout of material techniques, blueprint reading, CAD software, all those things are great prior knowledge to have coming into this project. Some other pieces that are there are whatever specific equipment you're going to use to build your sprocket that is designed within this. So there's some flexibility here. You could do like a hand cut with vertical bandsaw and files. You can use a plasma cutter or some sort of CNC plasma cutter or mill. You can also use an oxyacetylene torch to do the same sort of process with a similar end result. The one piece that wasn't mentioned there as part of that is a 3D printer as well. So that a 3D printer is a viable option to make these, especially if you're prototyping to do something else with this sprocket design. It's a great way to do it. So that comes around to our required tools and materials. Again, some sort of fabrication equipment that would be the piece you'd actually manufacture these with your students. And then some other manufacturing processes could include a belt sander to clean things up, a drill press to drill some holes in it and mount it as you need to whatever you're building, if you're extending it that far. Clamps, holding device for the drill press, the drill, drills themselves in various sizes for what you need. Definitely files, hand files, both round and flat. And stock material is another big important piece there as well. You need some material to actually make these. Here's some different examples. Like I said, there's some different entry points with this, so we can actually use our 3D printer. The first two here are examples of 3D printed designs of our sprocket build. And the last one there is a plasma cut sprocket that's actually been a little bit used as well. It's been prototyped into something here. The materials included in this presentation also have student resources, things about drive ratios and gear ratios, things like that. The first lesson is actually explicitly on gear ratio, so talking about how we calculate, one gear to another and those sort of processes, making a design plan for whatever sprocket we're going to cut out here. I'm not directly using gear and sprocket interchangeably. I understand they're two different things, but what's great about the sprocket design here is that it is a entry point into gear ratio. It's an entry point into talking about how this could apply to further automotive and mobility sector processes. So even though we're building sprockets, it could change and it could extend into a gear ratio piece as well. And then your actual sprocket fabrication is lesson 2. So going through how to do a bit of the design work, going through some of the processes to make a 3D printed or 3D manufactured prototype. So even if you are doing a CNC cut gear after, it's not a bad idea to have a 3D printed prototype and compare the results. So that's the breakdown of lesson 2. There's a bunch more materials in the actual slideshow. I'm just giving you the highlight reel here. Safety. So there's links back to the OCTI Safe Docs and the Tool Safe videos. That way you've got some points of reference for some safety lessons that tie into this. This whole thing is supposed to take about 3 to 4 days. Depending on how you do it, you might want to extend it into a few more things. It really does depend on your own personal preference and the amount of time you've got with the students for this. It's fairly flexible that way. There's also some other video guides, so some outside references, mostly just some YouTube videos on a bit more depth in the different areas of like gear ratio, how to cut some of those gears, torch basics, things like that. Also some CAD tips as well. There's an assessment that goes along with this to assess the outcome of those 2 lessons. So, the final manufacturing of the sprocket based on how the design process went for you there. And then lastly, as part of this, there's some other resources attached to this. And the primary one is the Ontario Vehicle Innovation Network Skill and Career Navigator. And so this is a resource that has been created by Oven for people just like our students and teachers as well. So what's great about this is that it is a hub for information to relate to the automotive and mobility sector moving forward. So things like electric vehicles, autonomous vehicles, stuff like that. There's going to be information about career options here in Ontario directly linked to those sectors. So if I just scroll down, there's 4 main pieces here. We've got the Learning Hub that has basically an overview of some of those technologies and what's actually happening in Ontario in regards to that, some of the different manufacturers and new technology programs that are happening around here. There's some labor market insights. So if people are interested in some career opportunities and where there's space for them in those, there's some information there they can sort through. Talent strategy roadmap, and it sort of links also to this last one, which is the personalized career path. You can actually put a student down with this and go through a bit of a plan as to where they might see themselves fitting in some of these modern, highly technically advanced career options that are available right here in Ontario, so that if they're doing some post-secondary planning, they can work through some of this as part of that process. So some really good resources here. I hope you find some value in these programs, and I hope you find some value in this project about Sprocket builds specifically. Thanks for your time.